Welcome back everybody to Rikers Island ICND1 training course. In this video, we are going to wrap up the routing section with breaking down how RIP version 2 works for IPv4. Now, I went ahead and in between the previous video and this video, I went ahead and I got the rest of the infrastructure all working. So IP addressing is in place and things like that. All we need to do now is enable RIP everywhere that we want RIP to work, and away we go. That is what we need to focus on now. So what we're going to do is we're going to go ahead and focus on understanding what RIP does, and then we're going to go ahead and start implementing RIP. Okay, so I'm not going to do anything fancy. It's going to be a very basic setup or very vanilla deployment of RIP, and we're going to go ahead from there. So I'm going to cover a couple things about RIP that you need to know exam-wise about it from a overview and a protocol perspective, and then we're going to go ahead and get into the nitty-gritties of it. So we're going to focus on the difference between version 1 and version 2 for RIP version 1 and for RIP version 2. We're going to talk about enabling RIP version 2 and then the network command. So before I get started in actually demonstrating how to deploy RIP and stuff like that, I want to go over some of the details behind it. So one of the first things we're going to hit is RIP as a whole. Actually, RIP as a whole, RIP v1 and v2 both use UDP port 520 for communication. So what that means is when they're communicating back and forth, the host router, so the router closest that you're running RIP on, will have UDP port 520 enabled. That is going to be how communication between the two RIP speakers is going to work. Okay, that's where you send your data back and forth. With it being a UDP, it sends it RIP has this every 30-second update mechanism in play, and it has a stateless manner, meaning it never holds the state of the network. It's always sending the data out. So what ends up happening with RIP is when you type in router RIP, it's enabling version 1 by default. Okay, so what ends up happening is you enable version 1. Version 1 will advertise the prefix and just the prefix. There's no subnet information. This is what they call class full, because it's going to say, you know what, if you type in 10.0.0.0 or 172.16.0.0 or 192.168.0.0, it's automatically going to fall back to the class full boundary. So this is going to be a /8 in this particular instance. That is what version 1 will do. There is no prefix information. It does not care. Now RIP version 2 was brought out, and that is going to take that to the next level. Here you advertise the prefix and the length, and this turns it into a classless protocol. Classless in the respect of it doesn't care what the subnet mask is. It's going to advertise it regardless, so it leverages the variably length subnet masking capability, or CIDR, classless interdomain routing. It's going to incorporate these functions and advertise both the prefix and the length, and that is going to be how you move forward with advertising routes. So if you have, let's say you've got 4 interfaces that fall underneath the 10/8. Let's say you've got 10.1.1.0/24. You've got 10.1.2.0/24, the 10.3.4.0/24, and 10.5.6.0/24. They all start with 10 here in the first octet. Then it's 10.1.1.0, 10.1.2, 10.3.4, 10.5.6. So that is your subnets you're advertising. You will actually see these routes then show up in the routing table with v2 enabled. That is going to be how it's going to show up. Now, when that is advertised and everything goes back and forth, when you use version 1 or version 2, what's going to end up happening, you are going to learn about other RIP routers, RIP speaking routers, by utilizing the link local multicast capability of 224.0.0.9. This is .9 indicates a RIP speaker. What you end up doing is if I have a connection like this, where let's assume that I've got a bunch of routers. Let's say I have a point-to-point and then I have a LAN segment sitting in between here. I've got 1, 2, and 3. It doesn't care whether or not that it's a point-to-point connection where only routers 1 and 2 will be talking to each other, or if there's a LAN segment where routers 1, 2, and 3 will be talking to each other. It does not care. What it focuses on when it's doing its job is it will send 224.0.0.9, so it'll send updates out this way via multicast and updates out this way. 2 will send updates out this way. 1 will send updates out this way. And they're not directed necessarily to router 3 in general. Actually, let me go ahead and clean that up a little bit so that makes more sense. Go to a thin line here and just erase this real quick, because this will make more sense once I get this rolled out. It actually is more, because I don't want to confuse anybody. I know the networking itself is already complicated enough without me confusing things. He'll send .9 out this way, out in the LAN segment, .9 out this way on the LAN segment, and this guy will send .9 out this way. So what they do is they send they ping, or they all join. Let me be specific here. They join the 224.0.0.9 multicast group. By doing that, whenever they send updates, anybody listening for that, which would be whatever the prefix length is, we'll say .1, .2, and .3 respectively, you're going to be learning about those peers. And then what's going to end up happening is router 1 will send updates to 2 and 3. 2 will send updates to 1 and 3. And 3 will send updates to 2 and 1. That's going to be how you update the information. And you only tell the router about what you know about. Okay, so our RIP routing table, once we get it rolled out, will be quite large, because we're going to have a bunch of individual prefixes we're going to run out. Now, I'm going to, one of the things that I'm going to do in ICND1 that I'm not going to do in ICND2 is I'm going to enable RIP everywhere for the simplicity of just showing you how the protocol works. I'm going to move away from the paradigm of you wouldn't enable RIP on your WAN. You wouldn't enable RIP in the internet because it doesn't scale. I'm simply going to enable RIP everywhere there's a layer 3 routing platform, just to show you how the RIP protocol works. Okay. Now, what's going to end up happening here is when we type in the version 2 command under the RIP routing process, and we type in no auto -summary, what auto summary is going to do is auto summary will take the classful boundaries and try to summarize them down to a single advertisement. Well, I don't want that to happen. I want to have a full RIB of routes, because then I don't want to potentially black hole anything or have RIP go, you know what, I'm really not sure. Again, now RIP uses the hop count as its metric. How many hops to the destination? That is what it's going to do. Hop count for metric. That is going to be how it lays that out. The other thing too about RIP is we can advertise a default route. What do I mean by that? I can sit there and advertise a default information originate from the internet-facing router and propagate that into the routing table. What that's going to do for me is, regardless of where I'm in the network, I'm going to look in the routing table and say, you know what, I am, wherever you are in the routing table, you're going to look at what type of traffic you're trying to forward for. You're going to look at the destination IP and the layer 3 header. You're going to look in the routing table. If you have a longer match routing will always win every day, unless you have some sort of mechanism in place to override the longer match routing paradigm. If that's the case, then you'll handle that as you go along. Now, with that being said, let us talk about the network command. Okay, so in order to get router RIP to work first, the first command you're going to type in is router RIP. Then you're going to specify version 2. Then you're going to specify no auto summary. I'm not even going to bother showing you RIP version 1 because of the fact that it's not on the blueprint. What I'm going to then do is I'm going to type in the network command on the left side of the network. I'm going to type in 10.1.0 or 10.0.0.0. That's all I can type in. It will automatically learn what's going on. Now, by typing in the network command, what you are doing is you are sending RIP hellos out interfaces that start with 10. Now my network command is going to be 10, 0, 0, 0. So what's going to end up happening is it's going to say, you know what? In the second, third, and fourth octets, I don't care what the IP address is in this particular area. As long as it falls under 10/8, I'm going to send RIP hellos out of it, and then that is going to be how I advertise routes. Technically speaking, what you're doing is you're announcing routing topology information. IGPs don't actually advertise routes. All they do is they form neighbor adjacencies with each other and they exchange routing information. That is what routing protocols do. BGP is the only protocol that will allow you to advertise advertise routes, because BGP by default does everything statically. It does everything. You have to manually configure everything. So that's going to be how we go forward with our configuration. So what I'm going to do with everything we've talked about so far, our topology is pretty much good to go. We're going to go ahead and take a look at getting this guy up and running from here. So our topology is completely up and running. I have verified, so just to bring everybody up to speed as to where I'm at, what I'm going to do is, actually I'm going to go ahead and clear the screen because there's probably some stuff on it. What I'm going to do is I'm going to prove to you that everything is working. Now PC3, over on the far right of the screen, I have PC3 configured, and the 192.168 network is good to go. I'm going to go ahead and I'm going to ping from PC3 to PC1 up here. Okay, I'm going to hit the up arrow and ping. I can ping that IP address. Let me just show you something. I am pinging from 192.168.10.10. That's where I'm pinging from, but I'm trying to ping 192.168.40.40. If I do a trace route to 192.168.40.40, you're going to see that I hit my default gateway and then I'm routed towards PC1. So with that being said, I know I'm in good shape there. What I'm going to do is I'm going to do a left to right getting the WAN up and running, first of all. So that's the first thing I'm going to do. I'm going to go ahead and get routing enabled up here. I'm going to go to global config, router RIP. I have a couple of options here. I'm going to type in, actually expand this out so it's probably a little easier to read. Type in version 2, no auto. And then what I'm going to say is network of 10.0.0.0. That's all I can type in. So I've typed that in. Do show run section RIP. Oh, it doesn't like RIP. Begin RIP. So here's my configuration. I've got these routes in here that are good to go. I've actually got to come out of here and type in, note this, I got to pull this default route out of here. Actually, I can do it this way here. No IP route. I want to pull this out. At least that, and then no this guy, because this guy will take precedence. So I got to get the static routes out of there. So I've done that now. Now I'm going to go over to switch this guy. Config T, router RIP, version 2, no auto, network of 10.0.0.0. Now what's going to end up happening, if I do a show IP route, you'll see that I have RIP routes learned. I'll have the 10.1 and I'll have the 10.1.30, right? So I have that. Now if I go over here to switch 1, and do the same thing, I do a do show IP route, I'm going to have RIP route. I'm going to learn the 10.3.196. So I'm going to go ahead and move on, because of the fact that in this case here, I am not using any, because of the way that the network was built out, I'm using switch 1 as my primary exit point to the network. I haven't configured any type of first hop redundancy in play, so we're not going to be using both switch 1 and switch 2. What I'm going to do now is I'm going to work my way to the right. I'm going to come over here, router RIP, version 2, no auto, and I've got to do one thing real quick. I've got to go see what my IP address is. I'm going to do a do show IP interface brief and network of 10.0.0.0 and network of 100.0.0.0. So there we go. So now we have that in play. I'm going to come down here and do a show IP route, and now I've learned RIP routes in. So that's good. Now I know how I'm going to be starting to forward. The routing table will start to grow at this point. I'm going to go ahead and I'm going to take this information over here to this guy, and I'm going to repeat the process. At this point, it's going to be just a lot of repetitive router RIP, version 2, no auto, do show IP interface brief, network of 100, and then do show IP route. We're starting to learn RIP routes. And that's exactly what you'd expect to see. So I can come over here, do the same thing on this guy, do show IP interface brief, and I've got to come over here and do router RIP version 2, no auto, network of 192.168.0.0, and network of 100. Now the reason I'm configuring things the way that I'm configuring them is because of the fact of the way that operationally things are going to work. Let me come over here, and on here, let me do a show IP route again. Now you'll notice my routing table is getting much larger. Now you'll see that my routing table in here, I have, you'll notice that for my default route, I've got this route here injected. And I'm seeing 192.168.100. Okay, so I see that there. The problem that I'm going to have, and you're going to see as you move a little further along, and I'm glad it worked out the way that it did, is I have the 192.168.2 network, right? If I type in out here, I do a show IP RIP database, I'm alerting a bunch of routes. But if I do the same thing over here, show IP RIP database, I'm not learning the 192 networks. Notice that? I'm not learning anything. The reason for that is when I'm typing in the commands on here, I have to be more specific with anything 192.168. So router RIP version 2, I have to type in do show run pipe begin RIP. So there's my command. I have to type in no, and I have to pull this guy out. I'm going to copy and then paste it. I have to type in network of, and I have to do a do show IP interface brief. I have to be more specific. I have to type in network 192.168.2.0. Okay, now I come back over to this guy, and I hit the up arrow, and now I've got the 2 network in here. So I have to be more specific when I get into the class C address block. So I'm going to continue to do that over here. So I have to come over here and config T, do show IP route, IP routing, do show IP interface brief. I type in network of, or router RIP version 2, no auto, network of 10, and network of 192.168.2.0 and 100.0. Okay, so now I've got that going on here. I'm going to continue over here. I'm going to loop myself back around to the other side of the network. Router RIP version 2, no auto, do show IP interface brief. Network of 192.168.10.0.20, 40, 100, and network of 10.0.0.0.0. And then I can go in here and do show IP route, and I've got, well, once it, oh, you know what? Do show IP route. Was that too soon? Why am I not learning anything from? Oh, that's because, wait, hold on. Do show IP route. So he's learning stuff. Okay, let's try this again one more time. There it goes. It took a little bit longer than I was. I'm impatient. That's my fault. So you notice my routing table is starting to grow. So we'll cover this here in just a minute. We'll verify RIP in another video. I just want to make sure that I get the base configuration up and running. So I'm going to go ahead and expand this out a little bit more as well. Router RIP version 2, no auto, network, or do show IP interface brief. Network of 192.168.2.0, network of 192.168.52.0, do show IP route. And what's happening, and the reason why it's taking longer than anticipated, is because of the fact that you have to wait for RIP to advertise. You have to wait for RIP to go through and run calculation. And then once all that is situated, do show IP interface brief. The interfaces that we want to have up and running are up and running. So, and momentarily, this might take a little longer than you anticipate, but eventually it will come to fruition. Now, I will double check my subnetting to make sure things are working here the way that they need to be. So let me just double check on R5 and show CDP neighbors. So I have the 3560 here, and I want to make sure that show IP interface brief ping 192.168.2.194. I should be able to ping. Okay, there's my problem. So I'm going to come back over here to this guy. I'm going to do a do show CDP neighbors. I should see R5, which I do, and I need to go to do show interface trunk, and 5 is a trunk. That's the problem. So I need to go to interface fast Ethernet 0/5, type in switch port, and do show VLAN brief. And I have a VLAN called WAN here ready to go. So I need to type in switch port access VLAN 30. Switch port mode is access, spanning tree port fast, because I want the link to come up right away. And now do show IP interface brief. VLAN 30 does not have an IP address on it, so that is the problem. So let me go ahead and pull back up on R5. And R5 is 193. I'm trying to get to 194. So I need to go type in interface VLAN 30, IP address of 192.168.2.194/30. Okay, so now that I've got that in play, do show run pipe begin RIP. I do not have that network configured, so router RIP, network of 192.168.1.30.0. Or actually, sorry, that's going to be 2.192. Should be that range. So do show run pipe begin RIP. So it's in cap. It's already got that in one. There go. And then we're going to do a show IP route. Show IP route. And momentarily we should get that one up and running. So let's go ahead and try to ping that guy. Okay, so we're still having a ping issue. Okay, so on R5, go Control-Shift-6 on that. Show run on port. So I'm good to go there. Show CDP neighbors. Switch 7, fast 1. Let me just make sure that everything on this guy is good to go. Show run, fast 1. Oh, you know why? Because I didn't, you know why? Because it's in, do a show VLAN brief. Hold on, did I? Oh yeah, okay, I used the wrong interface, that's why. I bet you we do show CDP neighbors. That's me. This is me going too fast. Switch 5 is on fast 1, not fast 5. So I need to go to, in fast 5, I bet you connects down to a switch. It does. So I'm going to go up here and I'm going to snag this config right here. I'm going to copy it. Switch 5 is, I'm actually going to go back to interface fast Ethernet 0/5 and type in no switch port access VLAN 30. No switch port mode access. And now that's been up. So interface fast Ethernet 0/1, switch port access VLAN 30. Switch port mode is access, spanning tree port fast. And then, so now if we come back over here to this guy, let's ping that IP. Now that works, and then do a show IP route. And then momentarily we should get show IP RIP database. Okay, so it's directly connected. Let's do this. Does this guy have a RIP database? Or show IP route? Okay, this guy's got a bunch of stuff. And He's got 2.196. There we go. So now we're good to go. So now we have routing in place. That's why I wanted to show you this live, so I'd have to troubleshoot it to make sure everything was working the way that it needed to be. So we're going to go ahead and close this one out and close this one out. Now, the ASAs do not support routing. So if I was to click right here, they don't support routing in the respect of, hey, I need to enable router RIP. They just don't do that. They come in here for any routing that they might do. This is going to be simply static routes. That's all that they're going to do. They're not going to do anything beyond that. So that's what the ASA can support. I'm not worried about that right now because I'm going to be showing you guys how to handle that in an upcoming video. But what I am going to do is I'm going to show you here how to do some basic configuration here. So what I'm going to do is I'm going to come in here and I'm going to point to the 10 network. I'm going to point on the ASA to the 10 network. I'm going to point that back towards R3 on this side. So I'm going to go to global config. I'm going to type in show name if. This is going to let me know show. Oh, it doesn't let me do that. Show interface IP brief. So normally in an ASA, if you were to type in show name if, it's going to show you what the name. Do show switch VLAN. This is where this would come into play. This inside and outside. I found out through doing some testing that having a third interface on the ASA, because we have this interface Ethernet 0/2 going down to this other router, this is not supported on this version of ASA. ASA needs to have an advanced license associated to it, and Packet Tracer I don't believe supports that. So what I'm going to have to do is go ahead and in here I have to tell the ASA, if you want to reach a particular subnet, you need to send it back out this interface. So I'm going to go up to the route here. I'm going to type in route inside and tell it the name. So 10.1.0.0/16. And then the next hop IP address is going to be 192.168.31.3. Okay? To do a show route, I'm going to have a static route that points into here. So now I should be able to ping 10.1.10.10. Actually, that's my fault. I don't have that 31 network in there. So let me go on this guy here. Show run pipe begin RIP. Yeah, I'm not running RIP, or I'm not routing on this guy. That's why. Config T, router RIP version 2, no auto. Do show IP interface brief. I'm gonna go ahead and grab. I'm going to type in network of 10.0.0.0 and network of 192.168.31.0. And then I'm going to go ahead and I'm going to say that do show IP route. There should be a. What I'm going to do here on router 3 is I'm going to type in a default information originate. And what that's going to do is it's going to advertise a default route into RIP from R3, and I'm going to say, now if I go over here to say, let's say this guy right here, show IP route, I'm going to have a default route that's going to come in. Now granted, I have already got a static route here, so if I do a show run pipe include IP route, I've got a static route here, so I have to pull this one out. Type in no, and pull this guy out, copy, paste, no, copy, paste, and no. This is why I don't like static routes. So now do show IP route. I should have a default route for RIP pointing towards VLAN 300 out towards R3. So now that I've got that, I can go ahead and close this guy out. I can go back to here and I can type in exit out of here, IP route 0.0.0.0, 0.0.0.0, and I can type in 192.168.31.1, and I can come in here and do a show IP route, and I'm going to have a static route pointing towards the ASA, Let me just go ahead and ping that. Ping 192.168.31.1. So I can ping the ASA. And what's going to do now is on the ASA, I can go ahead and ping now, or I should be able to ping. I can ping PC1. So if I do a trace route to 10.1.10.10, I do it, I should be able to trace all the way into the core to get from ASA2 or ASA1. I hit the first one I hit is router 3, then I hit switch 2, and then I hit PC1. So I go, yeah, so I hit R1 is the first hop, or R3 is the first hop. Then my second hop is is switch 2. Then switch 2 sends it to switch 1, which is a 10.1.2.1, and then from there it sends it down to PC1. So that tells me and let me go back here to switch 1 here. Show IP route. So what I have here in the network is I have a situation where I know I need to be able to reach a particular destination. So I have here on PC1, I'm going to go and try to ping 192.168.40.40. So it's going to have to go ARP for it. The first ping is going to get dropped, and I can respond to it now. Now I'm getting replies. Now I'm going to do a trace route to the same address. Tracert 192.168.40.40. I can trace to it all day long. It's 7 hops away, but I can get there. Now if I trace to, say for instance, I want to trace to Google. And let's say, for instance, for the sake of argument here, the routing that I would need to get in place in order to make this work the way that I need it to would be to, on this router, advertise I don't have routing enabled on this guy, and because I can't with the ASAs, I'm going to type in interface loopback 8888, and I'm going to type in IP address is going to be 8.8.8.8/32. Okay, so the next thing I'm going to do, I have to get a little ingenious with my routing here, so just bear with me, folks. What I have to do is I have to type in, ASAs don't support CDP. So what I have to do is I have to do a do show IP interface brief. So I'm going to say that the IP route to the 10.1.0.0/16, or sorry, /16 is going to be out 24.123.100.2. I'm also going to put one in here for the 192.168/16, but this is going to be at 101.2. Okay, so do show IP route. What that's going to do is on this guy here, if I look in the routing table, show route, I have a default route that points out towards R4 in this case. So now what that means, I did my ping to 192.168.40.40. Let's ping 192. Actually, before I do that, let me go ahead and on here and ping 8.8.8.8. Okay, so that's a good sign. So as long as I can ping from here to there and back, I should be in good shape. Let's go back here and ping 8.8.8.8. So I have the ARP for it. So I hit my default gateway. I don't know if it's going to pass it or not. I'm going through a firewall, and I'm not sure the firewall is going to catch it. Okay, so that's going to fail. So what I get to do, what the idea here is, because this guy, let's see if this guy can see it, ping 8.8.8.8. Okay, let me see why trace route to 8.8. It should follow the default route. It hits the firewall, and the firewall doesn't know what to do with it. So let me do this. The firewall should catch this and send it out this way. So let me cheat a little bit and type in route outside. 8.8.8, cheat a little here, 8.8.8.8/32 out 24.123.100.1. Okay, to show route. So I've added that static route here. So now if I go back over here to this guy, it should know how to route to it. Yeah, it's not going to, not sure why that's happening the way that it is. Config, I wonder, is there a way to global settings? I'm really not sure. This firewall doesn't give me a whole lot of options to work with. Because normally what I would do is I have the default route in here. I don't think I need a NAT. Let me go put the default. Instead of having the route there. So what I'm going to do here is I'm going to type in interface loopback 0, interface loopback, interface. Okay, so I can't. Okay, so I won't be able to do the demonstration the way that I was hoping to. So let me go ahead and put the loopback on this guy. So I'm going to type in interface loopback 8888, and then IP address is going to be 8.8.8.8/32. And then because the fact that it's got everything points to this router anyway, I should be able to ping now. I can ping quad 8, and now by trace route to quad 8, I should follow the default route path. So I get to where I've got to go. So that's going to be how we cheat to get the internet to work, but you could see the path that we took. If it's going to go, this guy gets it and says, you know what, because of the fact that it's going to be WAN routing, we can go ahead and go this direction. Now that we've got the routing in place, infrastructure maintenance, infrastructure security, infrastructure services, all of that will be way easier to work with because we got the routing in place. You have to have, and let me if you're outside doing something or not paying attention fully, stop what you're doing, focus on me for just 1 minute, please. It is absolutely imperative, really, really important that you have the infrastructure services, or I'm sorry, the infrastructure built. That is your layer 2 switching and your layer 3 routing on point, ready to go in place before you start trying to do DHCP, DNS, syslog, Active Directory, domain controllers, firewall, security, anything like that. All that stuff needs to be done after you've got the base configuration in play. And the reason for that is because a lot of the stuff that you're going to see throughout in the real world, this is going to be how you do this. Now, the way that I'm rolling this course out to you guys, this is how you should build a network. You want to make sure you have end-to-end reachability, then you can start locking it down. And that is the key factor here that everybody needs to understand. So I've got the network built and stuff like that. So let's go ahead and go to the verification. So actually, I'm going to go ahead and I'll split this video up, and this will be just a follow-on video. So we're going to work on the verification now. So we're going to start. I'm going to show you guys how to verify from the default gateway to the default gateway, so you guys know how to recurse to it, figure out how to read the routing table. So here's how we're going to go about doing this. So on the core switch, we're going to go ahead and I'll split this video in two. So I'll keep going, but I'll break it in half. So we're going to look at, we want to get to the 192.168.40 network. So we know we have reachability across the network to get there. What I'm going to do is I'm going to say, I want to get to show IP route, and it will let me to do a network. So we're going to take this right here, the 40, copy, and then paste. Actually, it doesn't like, there, that'll go. So what we've done is we're loading this via RIP. The distance is 120. This is the administrative distance. Okay. The hop count, the metric is 5. The hop count, the metric, they're the same thing in regards to RIP, and it's a value of 5. This is redistributing via RIP. Don't worry about that. That's irrelevant at the moment. Last update from 10.1.3.194 on Vlan 200 10 seconds ago. If you look in here in the routing table, your timer values here are 17 seconds. What ends up happening is RIP every 30 seconds is sending an update outbound, saying, you know what, here's what I know how to do. Here's what I know how to reach. This is one of the things that really need to be understood and important if you're going to go through and understand RIP in detail. So now what I get to do, go ahead and grab my, my pen tool here and switch it over to red for the moment so you guys can see what's going on here. You have this guy right here. This is the route we're trying to reach, the 40 network. My administrative distance never changes. It's 120. It's going to be 120 regardless of what goes on. My my metric here is the hop count. So I'm 5 hops away. So I have to go go through 5 different routers to get there. The next hop IP address I'm going to use is 10.1.3.194, and that's out of Vlan 200. So that's going to be the first thing you want to look at. So now I get to go, okay, great. How do I do that? So what I'm going to do first of all is I'm going to do a show IP. Is it Ceph supported? Awesome, it is. Show IP Ceph detail for IPv4 Ceph is not running. Huh? IP Ceph distributed. Excellent. Okay, so all right. Show IP Ceph detail. All right, cool. So this is a great way. So in the routing table, we verified our next hop IP address is going to be R2, and we know that we're going to be going out Vlan 200. But here's the thing: we got to go all the way down to 192.168.40. So we look at this guy. We say, okay, to get to 192.168.40.0/24, the next hop is 10.1.3.194 out of Vlan 200. Now, what we need to do is we need to figure out, okay, what interface locally do we have to leave to get out towards Vlan 200? So what I'm going to do is I'm going to do a show Vlan brief. I look at Vlan 200 and it says, well, 200 is right here. This is switch 1 to R2, and I have fast Ethernet 0/1. So if I do a show CDP neighbors, I know that here it doesn't show up. So am I out of luck? No, not at all. What I have to figure out now is I have to do a MAC address table. So show MAC address table for VLAN address table. So I look in here and I say, okay, 200, fast Ethernet 0/1. What I need to do is I need to do 2 things. I need to rebuild my layer 2 header, and my destination MAC address is going to be this guy right here, this A101. So I rebuild my layer 2 header with this destination MAC in mind. Show interface fast Ethernet 0/1. My local MAC address, my source, is going to be this guy right here, 4201. That's going to be my local MAC. That's going to be the source MAC. This guy right here is going to be the destination MAC, and then I forward on. So that's how you recurse from the layer 3 routing table into the Ceph table, into the MAC address table. That's how your frame rewrite process happens, and then you send it out towards router 2. The router 2 does the exact same thing. It recurses over and over and over again. It's a little easier to do here. We do show IP route. Go ahead and expand this out a little bit. 192.168.40.0. We learned that via RIP, and we learned that serial 0/0/0. Okay, so I'm going to do show IP Ceph detail, IP Ceph distributed, IP Ceph. So we learn 40 in off of the next hop is 10.100.1, and then we learned that out serial 0/0/0. Okay, so we have that in play. So the process repeats itself over and over and over again. If we do a show MAC address table, we're not going to learn any MAC addresses. You might say, well, why not? Well, because the fact that, if we do a show ARP, though, we will learn. We know we're learning 10.3.193 from this LAN segment here, but if we ping 100.0.0.1, show ARP, because of the fact that the serial addresses, they don't use MAC addresses. If we do a show interface serial 0/0/0, there is no MAC. If you look right here, there's no MAC address anywhere. right? So the MAC address is a little bit different. If we do a show controllers serial 0/0/0, we're going to see that there's no MAC address here. We have some clocking, but this changes some things. If you're used to seeing things in Ethernet and that's all you know how to work with, serial is a little bit different of a configuration. So we're using v.35 for DCE. v.35 is the cable connection type, and that all is well. Now we're using, if we do a show show interface serial 0/0/0. Oh, serial 0/0/0. Yeah, see, it's the hardware is HD 64570. All that's basically saying is the encapsulation is HDLC, the high level data link controller. So that's going to be one of the things you got to keep in the back of your mind as you're sending data out, is there's no MAC address in serial. There is none, because it's a point-to-point connection. It doesn't need to worry about it. So that's going to be one of the capabilities there. I can't verify the MAC address table here because Ethernet is where MAC addresses live. MAC addresses do not live inside of the serial world. So with that being said, that is going to be how I forward my data. So now what we get to do, this is the basic breakdown to how you would go about verifying the configuration. I can verify from a layer 3 perspective and Ceph, where I'm going to be learning my stuff. So here again, if we do a show IP Ceph detail, we can look at, well, let me look at a specific output. Show IP Ceph. Gigabit. Let's see here. Show IP Ceph. Well, let me do a. Okay. It gives us very basic information here. It'll give you more information on these guys right here, but it's all good. So beyond that, that's pretty much what you can expect to see as you're going along here. And we will take a look at examples as we move forward. But that's pretty much what I wanted to make sure you guys understood. So when we get into infrastructure services, infrastructure security, infrastructure management, so let me give an example of how that would work. From here, go to the command prompt, and I'm going to go ahead and I'm going to ping 192.168.100.9. Now what am I pinging? The first one's going to time out. Let's see. Did I advertise that one? Oh, you know what? I bet you I didn't advertise that one. What I'm advertising is the loopback of, or the VLAN 100 interface of switch 9. So let's go here real quick and do a show IP route. What do I know how to reach? I know how to reach 1010. Do I have advertise? I do have. Does this guy know how to reach the 100 network? Show IP route. Oh, that's why. That is why. Okay, so that's an oversight on my part. So what I've got to go do is it won't advertise a connected network globally because they all have the same prefix. So what I'm going to have to do is have to go in here and I have to tweak something real quick because the management network, if I was to ping 192.168.100.3, it's not going to work. So, and the idea here is, oh, okay, it works that time. But if I do 9, that should technically work. But it's not going to because it's got a longer match than the default. So what I'll have to do is I'll have to come in here and, can I do 4? Let's do 4. 4 should work as well because it's locally connected. Okay, so that should work as well. That switch 4 is over here. If we do a show IP interface brief, IM100.4. So what I'm going to do is over here on this side, I'll make these guys 100.101.4, and I'll go to global config, and I'll type in interface VLAN 100. IP address is going to be 192.168.101.8/24, and do show run pipe begin RIP, and I will go ahead and I will pull out router RIP no network 192.168.100.0, write that 101, and then do that, and then I'll do a do show run begin RIP. I'll take this guy right here, and I will copy it, and then I will come over here to this guy. I will paste that information, and then I'll take, let me do this real quick, expand this out so it's easier to read, and I will type in 100, go to the beginning of the line, type in no network 100. So now if we go back over here to this guy and do a show IP route, we should have the 101 network in there now, which we do. So now if I come back over here to this guy, and I have to go to interface VLAN 100, IP address of 192.168.101.7/24, and do write, copy that, and same thing over here. How long has that been lasting? That's been lasting a while. Let's do a show interface trunk. Interface VLAN 100, interface VLAN 100. IP address is going to be 192.168.101.9/24. The problem you're going to have is if you have the same subnet configured, in this case here, like switch 1 has it configured on the other side over here, and it's local to this network, right? Well, the problem is I'm hitting this network and it says, you know what? I've got a longest match. I'm a /24, so I'm not going to drop down and use the the default because I don't need to, and I'm not learning a 100 network because it's already locally connected. So you're basically black holing traffic, black holing the management over here on the right hand side of the screen, over here. So I have to be more specific and use a different configuration. So by doing this and changing the interface VLAN 100 and changing the IP address to 192.168.101.10 and giving it a different IP address, if I come back over here to this guy and I ping 192.168.101.9, now it'll ARP for it, and then it'll have to, eventually it should start to ping. The first time it'll say request timed out, and it should start to respond. It might take it time for it to propagate. Not sure if that's actually going to work or not. Let me go ahead and change it over here. Let's see if there's anything that I need to manipulate over here. So we're going to ping 192.168.101.9 from here. We're learning the route. So let me go ahead and trace route to 192.168.101.9. So 2.198. Oh, I see what's happening. You know what? That's my fault. That's another oversight on my part. So what I've got to do is on here, it's hitting this router right here. We do a do show IP interface brief. I am 198, right? But I've got VLAN 100. If I do a do show IP route, it's possibly down. So it's actually, the problem that I've got now is that it's black holing the traffic. So what I need to do is I need to jump out of here and do a clear IP route star show IP route. I'm going to have to relearn the routing table. I'm going to have to wait for the next routing update to come in. Okay, so there it is. So now it's learning. It's got 100. So starting to learn them in. I need to learn the 100 network in yet. And it's not learning that one in yet. That's the problem. You don't see the 100 network sitting in here yet. And did I advertise that over here? Control-Shift-6 over here. Show run pipe begin RIP. Let's see, show run. That would be the problem. So let me go back to global config. Router RIP version, or I can type in network of 192.168.100.0 and do that. And the same thing over here on, if I do that back on this guy, now we have the 100 network in there. Just learned it. Do the same thing over here. Show IP route. We've learned the 100 network in. And we also learned the 101. So I need to come back over here to this guy and do that same trace route again that I just did. Just do that ping again. That should work now. Not sure why it's not. Let me see. Show IP route. What am I missing here? So I get to 198. 198 looks at it. This guy sees it. He sees it come in. Do a trace route to 192.168.100.1. Okay, he gets all the way there. So 100.1 gets all the way across. Let's shorten it up and do, what is this guy? Show IP interface brief. 101.8. Okay. Let's do a Control-Shift-6 there and do 100.8. Okay, so that one works. So it's the fact that it's you know what I can do to fix this is you can't use /24s here. So I will have to configure this as /32s or individual subnets. So the simple fix to this would be to go to global config, interface VLAN 100, IP address of 192.168.100.1/32. Beg your pardon? Bad mask? Not sure I've ever seen that before. Why is... Let me try doing this. Let me do interface loopback 100, IP address of 192.168. Actually, I gotta do this first. Interface loopback or interface VLAN 100, no IP address. Interface loopback 100, IP address of 192.168.100.1/32. Okay, so all right, well, let me do it that way. So I will get rid of the VLAN 100 interface. So the simple fact here is I'm going to do a. Can I do a? No, I can't. I will cheat a little bit here. I'll create a. This is how you. If you have to do a bunch of changes on the same boxes over and over and over again, you go to global config, or you type in interface VLAN 100, no IP address. Interface VLAN 100, or loopback 100, IP address of 192.168.100. Whatever. So in this case here it'll be 2 and then be /32. and then you take this right here, you copy this, and then you go over to this guy, and then you paste this. Okay, does this not support loopbacks? Interface, loopback, and it's not a supported command. Okay, well, I'm going to go into interface Vlan 100, IP address of 192.168.100.3. Okay, so, for the sake of argument, I won't worry about that right now. I'm going to just focus on the main devices here for management. I'll go to global config, I'll paste that config, and then I'll come over here and I will tweak this guy to be 101, and this to be 101. And then I will go to here and config T, paste, and then paste on here. So there we have it. So now if I go over here to this guy and I try to ping .8, that should work. I know I'm going completely across the network here. I should try to do it more locally. Let's see here. What is the do show IP? Oh, I see why. Okay, so that'll change that. This guy needs to get tweaked as well. This guy is going to be 7. And this guy here will be, this guy's got 2. Okay, so the reason why it wasn't working is if you try to ARP for a particular IP and you get in multiple MAC addresses, so R1 or switch 1 here was seeing a MAC address from switch 2 as well as from R2. He's like, well, I'm learning 2 different MAC addresses, so neither one is good. You can't have 2 MAC addresses mapped to the same IP. That is not supported. So now I can go back over here and do this. That works now. You see the TTL starting to drop. If I do a trace route to 192.168.101.8, I trace route across the network. I go straight across the WAN the way that it's supposed to be. That is how management is supposed to be, but I can tell you from fact that you don't need to have the switches that I'm trying to do the management on for this configuration. They support loopbacks. 100% support loopbacks. It's just the fact that packet tracers' limited capabilities in this particular case don't support it. So that is a particular case that we're running into right now. So you've seen me play around some routing and some manipulation. So at this point in time, we are at a head when it comes to, we've come to a turning point in the course where we need to start. We've gotten the infrastructure up and running. Now we need to go ahead and start working on the management, the services, the security, etc., and go start working on that. So that's where we're going to start focusing our time and efforts in as we go along and go from there. Thank you so much for your time and efforts and your patience and your concentration, all that good stuff. I know this was for me it was over an hour long video. I'm going to break this in half. You're going to have the implementation and the verification and some troubleshooting. And that actually, I'm glad you guys got to see that because I had to sit there and think on my feet and go, okay, why is this not working? So, and then explain to you why it's not working. So that is one of the reasons why I do things the way that I do them, so that you guys can see, okay, how would an expert level engineer sit there and go, okay, why is this not working? Is this not supported? So I can sit there and then go, okay, this is why it's not operational, and then go and fix it. So with that being said, again, thank you for your time and for your patience and for your your attention. We are going to get into the less well-known things as we go along here, and it's only going to get better as we go along and go from there. So again, thank you for your time and patience. Until next time, guys, take it easy.